So today we will be starting exponentials and logarithms from the beginning. So the purpose of this session is to show you all the details between exponentials and logarithms, any connections, differences, what are they. So first of all, you have to understand the origin of these functions. Okay, so when you learn math, the logic behind it is very, very important, right? Unfortunately, some of us try to know the function and remember the function and then somehow use the function here and there. So we people think we know math. So it's very, very hard to do math like this, right? So there is you can survive. If you are a smart student, you can survive up to some extent, but after that it's very hard. Okay, so the purpose of this session is to teach you each and every piece inside these lessons. Okay, so firstly I will explain what is exponential function. Exponential and logarithms, right? So those are two different topics but works together. So exponential function, as I promised you, I'm going to do these things from the beginning so then I don't have to revisit, right? Exponential functions. Now function is something like this, right? So function is the equation which has x and y, independent and dependent variable, like this. So there is another condition which this should satisfy, which is called vertical line test. Vertical line test. Okay, so if you have a function like this, y is equal to x plus 1 versus x squared plus y squared is equal to 1. So this is a circle, right? And this is a straight line. Yeah, so now you will see that this is the equation. This is the equation with x and y, and this is the equation with again x and y, right? However, if you do the vertical line test here, you can see there is only one intersection. If you do vertical line test here, you can choose any point, then you have two intersections, right? So if you get two intersections, this is not going to be a function, not a function, but it's equation with x and y. This one is a function, this is a function. Okay, I hope this is clear. So you know what is a function now. Now exponential is a function. Okay, so let me explain this to you as usual. So this was originated like this. You know y is equal to x to the power 1, x to the power 2, x to the power 3, x to the power 4, x to the power minus 1, x to the power minus 2. So likewise you can write so many functions, so many equations, or in this case they are functions, yes. So so many functions you can make, right? So this one is nothing but 1 divided by x. We call it rectangular hyperbolas. This one is nothing but 1 divided by x squared, right? So this is called truncus. This is linear, right? So this is linear. This is quadratic. It's a quadratic function. So they have names, specific names, right? So this is cubic, right? So likewise they have their own names, right? But when you go to x to the power 22, there is no specific names, right? Specific names are given for most popular functions, right? Now so we are going to learn about these functions and this function. This we already done, right? So grade 5, 6, 7, right? When you are doing selective school, maybe you have done this. Quadratics we might touch in the future, but you mostly have done this. Cubics we have to do. Okay, so we will be doing that in the future. Now this family, this whole family, right? This whole family, this whole thing is called family power functions. This whole family is called power functions. Power functions. Right? Power functions. This whole family is called power functions. Now, if you think about swapping the variables, so I meant this. So x to the power 1, 2 to the power x, 3 to the power x, 4 to the power x. So likewise, you can have many, right? So this is, you can have many, right, in the left hand side too. So the only difference between these two is you are going to swap these two, right? So if you swap these two, you get a different function, right? You get a different function. This family is called exponential family. Exponential family, right? Exponential family. So now, from now onwards, you should know what is the exponential function, right? No one is going to ask, but this is for your understanding. So then only you can think. So exponential function is when the variable is in the power. Variable is in the power. Variable is in the power. So this guy is called the base. Base 2, base 3, base 4, something like that. Okay. Now you might think, can we have a real number as a base? Yes, you can. So for example, 4.125. 4.125. Okay, 4.125. So 4.125 to the power x is the exponential function. Yes, this base can be anything. It can be a real number, it can be a integer, right? So that you understand. Okay, now we call it exponential function. Okay, now if you really understand exponential, this family is a function family, right? So how do you know it's a function? Because we understand y is equal to x. So x and y is there. It is the equation. But there is another condition to satisfy, which is vertical line test, right? So that means it should be like this, not like this, right? So if you plot, for example, right? For example, you get y is equal to 2 to the power x. If you plot this one, if you plot, it looks like this. Right? It's 1 here. So this is how it looks like. Now, is it a function? We'll check. You have x, correct. You have y, correct. It is an equation, correct. You draw a vertical line test, you get one cut, correct. So it's a function. So that's why we call it exponential functions. Okay, it should be very clear. Now, how to get this shape? Stop me if you have any questions. How to get this shape? So that is very easy. Now, when you are in grade maybe 6, 7, right? If someone asks you to sketch or plot y is equal to x plus 1, how you did that? So you took x values here, right? So you took x values 0, 1, 2, 0, 1, 2, something like this, minus 1, minus 2. You can have any other points, and then x plus 1, right? X plus 1 would be 1, 2, 3, 0, minus 1, something like this, and this x plus 1 becomes y. So that's what this says. X plus 1 becomes y. So y becomes nothing but x plus 1. So you're going to copy what you write. So minus 1, 0, 1, 2, 3, like this. So from here you will see this is your output. This is your output. From here you will see this is your input, right? So for this input you call it mathematically independent variable. Independent variable. For this one you call it dependent variable. Okay, so dependent variable. So this is how you plot functions by having data points. So what you do, so you have 0, 1, 2, so these are the x values, minus 1, minus 2. So then corresponding y values, so when x is equal to 0, y is equal to 1, so you put a dot there, right? 1, 2, you put a dot there. So likewise you get many dots and then you connect, right? That's what you did. We are going to do the same thing for exponentials, right? For example, y is equal to 2x. We are going to do the same thing. Okay, so I'm doing it from real scratch, so better to understand it properly. So I'm going to choose x values, right? So x values I'm going to choose, let's see, 0, 1, 2, 3, you can go on. Then minus 1, minus 2, minus 3, you can go on, right? So those are our independent variables. Now think about 2 to the power x. So what are the 2 to the power x values, right? So that should be 2 to the power minus 3, 2 to the power minus 2, 2 to the power minus 1, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Very easy. Then how do you do this calculation? So this is going to be 1. This is going to be 2. 4. This is going to be 8. So this is going to be 1 divided by 2. This is going to be 1 divided by 4. This is going to be 1 divided by 8. This is going to be 1 divided by 16. This is going to be 1 divided by 32. So when you go in this direction, you can see that pattern. Okay. Okay. Now you know properly, right, with your previous knowledge. Okay, let me show you that as well, as I'm going from real scratch. You know that 1 divided by 2, 1 divided by 4, 1 divided by 8, 1 divided by 16, when the denominator is increasing, you can see, when the denominator is increasing, then this whole thing is decreasing. This whole thing is decreasing. You can see 1 divided by 8 is larger than 1 divided by 16. This is common sense, you know, from grade 5, 6, 7. So that means they are inversely proportional. Inversely proportional. Right? Inversely proportional. So now if you want to draw this, right, let's think about this. If you want to draw this, when x is equal to 0, 1, 2, 3, then minus 1, minus 2, minus 3. So we'll try to fit the points here. So when x is equal to 0, y is equal to 1. Okay, first point. When it is 1, it's 2. Okay, somewhere here, second point. Then 2, 3, somewhere here. So you can have this kind of a non-linear behavior, right? Non-linear means it is not linear. If it is linear, it should be like this. Non-linear means not linear. Simple. Now, how do you take care of this side, right? So now 2 to the power minus 1 is half. Then you can see it's going like this. But it will never go to 0, right? So it's the whole thing is reducing. So that means this is 0.5. This is 0.25. This is going to be 0.125. This is going to be 0 point something. This is going to be 0 point something. But when you keep going, what will happen? This number can be 0.00001. The next number can be 0.000001. So something like that. It is not going to go to 0, but it will go to a very small number, right? So there you understand the asymptote. Asymptote means, you know, it goes like this, and then when you go further, it is a very small number and it goes like this without touching the x-axis exactly. Okay, I hope it is very clear. Okay, so this is how this exponential function 2 to the power x looks like. This is how it looks like, right? This is how the nature of it, right? So that means when x is increasing in this way, function is going that way, so that means x is going to infinity, y goes to infinity, that you can see. And if you observe this end, right, so you observe the top end, so if you look at the left hand side, you can see x goes to minus infinity, right, y goes to 0. This is called goes to. It is not exactly equal. Goes to, right? So that's the idea. So you can ask questions from here. So this logic you must understand. Okay, that understanding part I can't teach. Okay, I can show it to you. All the logics and all the pieces are inside here. So if you don't know, you can raise your hand and ask. Okay, good. So this is how 2 to the power x, which means the exponential functions looks like. This is how the exponential functions looks like. Now, example, suppose you have 2 to the power x, 10 to the power x, right? So how do you understand this? So you know, let me think let me tell you this. The shape of the function is going to be the same. Shape of the function is going to be the same. So suppose this one is 2 to the power x. Then we have to understand how 10 to the power x looks like, right? So the 10 to the power x looks like this way. Okay, so logically you have to understand without any confusion, right? Now, observation, 10 to the power x is, going on top of 2 to the power x in this region. That means after this point, which is x is equal to 0 line, right? But if you think about this, the green one is on top of this one. Why this is happening? You must understand it right now. So to address that, right, I'm going to get 2 points here. One point is here, the other point is here. There I'm going to take, for example, I'm going to take x to be 1 here, right? And I'm going to take x to be minus 1 here for simplicity, right? When x is equal to 1, so the coordinate at that point is going to be 1 comma 2 to the power 1 is 2, correct? The coordinate at that point would be 1 comma 10. Now, if you look at this, 10 is obviously greater than 2. So, this point should be definitely on top of this point. That's why this curve is above the green one. That is how you explain. Okay, let's go to minus 1 now. Right. Let's go to minus 1. Minus 1, it's so tiny, so I have to go here. So this point would be minus 1, and then that's 10 to the power x, right? Yeah, 10 to the power x. So that should be 10 to the power minus 1. So that should be 1 divided by 10. Right? So what about this coordinate? This coordinate is minus 1. 1 divided by, what is that? 2 to the power x, right? 2 to the power x. X is minus 1. 1 divided by 2. Right? Obviously, you will understand by comparing these two. You will understand half is greater than 1 divided by 10. So, we understood that the green color point should be on top of the gray color one or the other color one, right? Similarly, we understood that here we understood that 10 is greater than 2, so the brown color curve should be on top of the green color one. Okay, so this is the most bottom basic concept about how the lines are switching together. Now, if you look into the y-intercept, right? Y-intercept is when x is equal to 0, right? So you will understand there, at that point they are equal to each other. So let's try to understand that. When x is equal to 0, so it's going to be 2 to the power 0. Indeed, that is equal to 10 to the power 0, right? Why? Because that's going to be 1. So indeed, this is 1. So y-intercept is 1. This is how exponential functions looks like. Okay. So I taught you a very important concept if you are new to the class. Okay. Now let's think about variations, right? So we will try to play with it now, right? Variations. So we'll firstly think what are the variations, what are the possible variations, right? Okay. So now let's see. First variation can be what? So we'll think about the variations, right? Logically. So this can be y is equal to 2 to the power minus x. It's a variation, right? Then y is equal to 2 to the power 2x, right? Is another variation. Then y is equal to 2 to the power x minus 1. That is another variation. Y is equal to 2 to the power x minus 1. That minus 1 is outside. That is another variation, right? Then y is equal to 5 times 2 to the power x. That's another variation, right? Then y is equal to minus 2 to the power x. That can be another variation. Last one, y is equal to minus 3 times 2 to the power x. That's the last variation. Now, to understand these variations, we have to understand our previous basics as well, right? Which I will teach you down the road. Now you can see this x which is the independent variable, is multiplied by minus. If that happens, this kind of a variation we call reflection. Okay, reflection. So minus is associated with x with multiplication. This kind of a variation we call dilation, right? So you can see 2x, right? X is 2 is associated with x. This kind of a variation we call x translation, because you can see with minus, right? So precisely we have to understand. So this is dilation. Why? Because of multiplication. This is reflection, multiplication by minus 1, right? So the difference between dilation and the reflection is just this minus. So this is x translation. What about this? So this minus 1 is not strictly associated with x, but this is strictly associated with y. How do you understand that? So if you move this y to this side, so it's going to be y plus 1 is equal to 2 to the power x. Then you will see that, see, this 1 is associated with y. So that is y translation. So this is related to y translation. This is x translation. This is dilation. This is reflection. It should be very easy. Now, when it comes to here, right? So nothing is associated with x or nothing is associated with y, right? It is not translation. So this is called amplitude, right? So this function is multiplied by 5. So this is called amplitude. We will discuss that later. Now here the amplitude is -1, right? Here amplitude is -3, right? Now the crazy thing would be you get questions by combining all of these together. Example, you get y is equal to -5 times 2, right? Minus 2x plus 3 plus 9. So in this question, you have everything. You have y translation, you have dilation with reflection, you have x translation, right? So down the road, we are going to discuss all of these things. Now, whatever we are discussing here as properties, as variations, they are not just for exponentials, but these are applied for other functions as well. So in general, you have to understand that transformation topic, right? So if I see that you don't know that, I will help you like this to understand, but you make effort. All good. So I will show you a few of variations, like how to plot it, right? So I will go by questions, right? So if you want to plot 2x with 2 minus x, I will quickly do that for you. So that looks like, so 2x looks like this, right? Then 2 minus x looks like this. Okay, so this is 2x, this is 2 minus x. Okay, then if you want to have let's say x minus 1, right? So y is equal to 2x, right? Y is equal to 2x minus 1, right? So let me plot 2x. So 2x looks like this, right? So 2x minus 1 means, right? So what is happening? This is x translation, right? In the positive direction by 1, right? So that means, so all the points are moved by 1 here. All the points on this original curve is moved to the right by 1. So all the points like this. So that would look like this, right? So this is 2x minus 1. So this is 2x. So to understand this translation, you can take the most convenient point here, which is this point. Why it is most convenient point? Because you can see that's a y-intercept, right? So how this y-intercept move under this translation is what we are going to see. So this point should move to right by 1, and it is here. So x coordinate is 0. Now new x coordinate is 1. So this is our new x coordinate after translation. So why we choose that point? Because this point is more easy to understand. Otherwise, all the points, even this point is translating by 1. Okay, even this point is translating by 1, right? So all the translations we understand by just using this point. Okay. Okay, pretty easy. Now let's think about this now. Y is equal to 2x versus y is equal to minus 2x, right? So y is equal to 2x is like this. Y is equal to minus 2x. It's minus of the whole thing, yeah? It looks like this. Now it's your job to understand the difference between this and this, right? So we are not going to spoon feed you on that. So that responsibility I will leave with you. Okay. So this is 2 to the power x. This is minus 2 to the power x. Any questions, you can stop me. Otherwise, these are very general things which you can collect through your intellect. Okay, so there is a question asking, what do you mean by inversely proportional? Right? Okay. Let me address you that. Inversely proportional, right? I will explain this with some day-to-day examples, right? Proportionality. Right? Proportionality. So if you have y proportional to x, we call it direct proportional. If you have y proportional with 1 divided by x, we call it inversely proportional. So this is inverse case. Inverse case. Right? So this is the direct case. In the direct proportionality case, when x is increasing, y is increasing. In the inverse case, when x is increasing, y is decreasing. Example? Okay. Student proportional, student grade proportional to hard work. Makes sense. When you do more hard work, you get more grades. Next one. Student grade is inversely proportional to number of hours you sleep. More you sleep, more you fail. So that is the proportionality. Okay. Okay, all good. Now, is there any other questions? So let me clear the background, right? So the whole purpose of this session is to clear the background. The regular grilling I will do anyways in our regular class, right? So before you are going to be a victim in my grilling, so you have to have a proper background in your theory. So that's why we are having this session, right? So in these sessions, don't expect me to do challenging questions. These sessions are mainly conceptual theory. Okay, theory are usually pretty simple, but okay. Okay, so 2 to the power 2x and 5 to the power 2x. Okay, I will do that. So there is a question. This. Explain 2 times 2 to the power x. And what is the other one? Y is equal to 5 times 2 to the power x. Okay, so I'm going to add another one. Y is equal to 1 times 2 to the power x. Let's see how this works. So 1 times 2 to the power x, suppose it looks like this. Okay, so this is 2 to the power x, means 1 times 2 to the power x. So this point is 1. Okay, now let's think about 2 times 2 to the power x. So when x is equal to 0, it should be here, right? So when x is equal to 0, it should be here. When x is equal to 1, right? Think about this. When x is equal to 1, this coordinate is going to be 2, right? 1 comma 2. So for the other one, it should be 4, right? So that means it should be here, right? So it should go like this. right? So this is going to be 1 comma 4, and this is nothing but 2 times 2 to the power x we are discussing. Okay, so that shape is this. Now let's go to the other side, right? So minus 1, what will happen? So if it is minus 1, you go here, then this is going to be 2 to the power minus 1, this is going to be half, right? 1 divided by 2. And if you apply, so meaning if it is minus 1, this is going to be half, right? So half is that point, this point. If you put minus 1 here, right, so that's going to be 2 times 1 divided by 2 here. 2 times 1 divided by 2 is 1. So obviously that point is going to be somewhere here. So this indeed continues like this on top, correct? So that is what 2 times 2 to the power x is. Now if you want to understand what is 5 times 2 to the power x, indeed you will understand it should go like this, and this point is going to be 5, right? So for the other one, this point is 2. Why 2? I think you understand. When you put 0 here, this is 1. 1 times 2 is 2. That's where you get 2 here. Okay, so I answered that question. Yeah, so 2 to the power 2x and yeah, so those are variations, right? So think about this, right? So the best thing is now knowing these basics, right? So you can try to think about variations and plot it. Like for example, y is equal to what Yash is asking, 2 times 2x versus y is equal to 2 times 2x in the power. So this is what you're asking, right? The difference between these two. Yeah, you can plot it, but you have to understand the shapes are different, right? Definitely shapes are different, but both of them are exponentials. So exponentials, it should show you this shape anyway. How it goes, like one can be like this, one can be like this, or one can be like that. It's different, right? That would be different, but this shape is going to be the same. Okay, so that I will leave with you to understand. Okay, so basically we understood what are the exponential functions, right, and how to plot them. Firstly, you have to master this, right? The next topic would be next and the last one in our discussion, right, about exponential functions at this level would be solving exponential functions. Right. Example. So if you think about this, you can categorize this into 3 sections, right? So can think about 3 variations, I would say, right? First variation, wherever you go, only these variations you will see. You do VCE, you will see only these 3 variations. First thing would be 2 to the power x is equal to 8, this kind of a thing. Second thing would be 2 to the power x is equal to 7, this kind of a thing. Third one would be 2 to the power 2x minus 5 times 2x plus 6 is equal to 0, this kind of a thing. Okay. So in our regular class, we have gone through all of these things. If you want to brush up, so firstly we will discuss the first one. So before I go into the solutions, I will show you why they're different, right? So if you think about the first one, 2 to the power x is equal to, why this 8 is important? Because 8 can be written in terms of base 2. See, 8 can be written in terms of base 2. That's why that is one of the variation. Very simple, right? And if you look into the powers, so to maintain this equality, this x should be equal to 3. So answer here is very easy. X is equal to 3, right? Now you have to understand these words. This is an equality, right? This whole expression should satisfy this equality. So that means left hand side should be equal to right hand side. So to have that, this x indeed should be equal to 3. Common sense. Go to the next one. Now here, 2 to the power x, can you write 7 in terms of 2 to the power something? 2 to the power something. Can you write 7 in terms of 2 to the power something? Actually very difficult, right? Very difficult, right? If you don't have the calculator, if you have the calculator, you can at least try. If you don't have the calculator, you stuck, right? So there is another way to address this problem. There is a way to address this. Okay, that I will teach you later. What about this? When you see this kind of a question, very famous question, right? These three sections are very famous. This one is pretty much grade 7, right? This is okay, like I would say like grade 10, 9, 10, right? Maybe grade 9. So this is grade 10 and 11, right? Now when you see that kind of a structure, you have to understand quadratics. Now you have to understand quadratics lesson is important. Why you think about quadratics? You look at the shape of the given function. You look at the shape of the given function. So you can write this 2x as 2x times 2. Now to write 2x like 2x times 2, you should know index laws from grade 4, 5, I think, right? Index law says xm whole thing raised to the power n can be written as xmn, right? So here you have 2x, you should be able to write 2x 2. So this rule is used, okay? So it should come nonchalantly now. So minus 5 times 2x plus 6 is equal to 0. Easy. Now from here onwards, the game is easy. So you do a substitution, like let k is equal to 2x, and then you can go from there, right? So that part I will teach you later. The most important thing would be to construct this. And in the second variation, how do you deal with that 7? That is very important. Okay. So any questions? Okay, so I'm not going to overload you because there are new students here, right? All students, you have to bear with me. So this week you have to understand this lesson, okay? So in the next lesson, I'm going to discuss these two sections, how to get the answers, how to solve it, and then we'll discuss few example questions. Then I will move into logarithms, right? Hopefully I should be able to finish logarithms by next week. So I taught you everything from scratch, right? I don't have to have like 5, 6, 7 sessions to teach you exponentials. Exponentials are just this. If you know this properly, you are up to the mark.